let's get on with the data types in the MIPS r3000 architecture. So there are only three types of data really. There's the byte, the half word, and the word. And they all double in size, essentially. So nothing too complicated to understand here. Now, what's more interesting if you're not familiar with signed and unsigned values, though, is what the hell they mean and what's going on here. So, as you can see, the unsigned are only positive values, and signed are negative to positive values. The reason the range is essentially cut in half, and one part is negative and one part is positive for signed, is because the leftmost bit of that data type is used to say whether this value is positive or negative, but only when the instructions of the game actually believe it is a signed value or unsigned. So really, if for example you see FF in the game's memory, and you know that value is just a byte. Now, if you don't actually know if it's signed or unsigned, this value could either be 255 or -1. But if you check the code of the game, and you see that this is something that is only ever loaded as a signed value, then you can pretty much expect that for the rest of the instructions in the game, it's probably going to be loaded as a signed value too. So FF in this case would always equal -1 in decimal. And as you can see here, I've made a table to make it easier to understand. When it comes to binary, each bit from the right to the left doubles the value. So everything 0 is 0 either way, and 1 for the rightmost bit is going to be 1 for both, because, like I said, it's the leftmost bit that determines whether a signed value is negative or not. So let's scroll down. And as you can see here, whoa, there is a transition right here. Leftmost bit for decimal 80 is -128, which is the lowest possible value for a signed byte. Meanwhile, it's 128 for an unsigned byte. And I understand this is confusing, but this essentially just means that a maximum value of 255 unsigned is the minimal negative value of essentially 255 unsigned, but it has to become a negative value if it's read as something signed. That's really it though. It's not really more complicated than that, but the difference between signed and unsigned can make a lot of difference in your code, and it's really important to understand what is unsigned or signed, because there are some instructions that are going to behave very, very differently if you actually use one or the other, as well as when you load data, what's going to happen to your registers, whether it's signed or unsigned. And I would just like to point out that in MIPS r3000, there is no such thing as a floating point or a double. That is unfortunately only introduced in the PS2. So, I hope everything was clear, and oh, actually, I'm not done. Yeah, alignment. Um, so we have something interesting here. Um, I do not actually know how important it is. I do not know if the PlayStation console is able to handle things if you do not actually follow these standards. But as it is with coding standards in general, please just respect them because they make sense. They must be there for a reason. But yeah, when it comes to loading or storing data, because there are some instructions for that. There's some load byte, store byte, load half, store half, and load word, store word instructions. And those are going to be used on specific memory addresses, and you want to respect the alignment. What the alignment is that the leftmost byte should be rounded to the data type. So essentially a byte, well, is the smallest data type, and so you don't really need to align anything. You can load any byte that you want. For half words, however, you should only ever load when the end of the address is a multiple of 2, and for words, you should only ever load and store when the address ends with a multiple of 4. Now, there is something special as well with a stack, which is a multiple of 8. I actually don't know why, and I only learned this because Glenn's updated version of FFT Orgasm actually throws a warning if it's not aligned with 8 bytes. So let's take words for example. This address right here. So as you can see here, the correct values for this would be ending with 4, 8, C, or 0. So if you end it with a 3, that's not going to work. I mean, I don't actually know what's going to happen. I'm just not someone who likes to actually not respect the standards. So I don't know what would happen, and it would definitely differ from the console and from different emulators. The thing with coding standards is that you have some hacks like Alma that do not respect the coding standards, and it's going to work just fine in some emulators, and it's going to completely freeze other emulators, going to crash some, and it's not going to work on a main console. Ultimately, the console is going to determine whether you have respected the standards or not. If it freezes, then you have clearly done something wrong. And emulators, well, if an emulator is behaving differently than the console, then it's really the fault of the programmer of the emulator. And yes, there are some hacks that are popular and that, people like them, like Alma or Rad, that do not respect the standards. And I think it's just really, really unfortunate that just because coding standards were not respected, I understand why. It's because no one actually taught us these things earlier in the days of FFactX. But now I believe is the time to move on and make sure that those mistakes are not repeated, because it's pretty shitty to force on users a specific emulator to use just so that their hack can work. It's one of the problems that Celdia has with her original mod. it only works with specific emulators, which is a real shame because it is a good mod otherwise. And that's really it. You just have to respect the alignment, and everything's going to work fine, and FFT Orgasm is not going to throw you errors. I believe that's all I have for you in this video. Next video I'm going to start with the upcodes, and this is going to last a while because there are several upcodes. You can do nearly anything that you want, as long as it doesn't involve floating point numbers, since the architecture doesn't support it, and of course anything that is within 32-bit registers, of course. But you can do just about anything that you want within the hardware's limits, just like my signature on the forum says. So I hope you enjoyed this video, and I hope you look forward to my next one.